Greetings, physics students. Mr. Resentis again. I'm on Chapter 10. Follow along if you'd like. This is thermodynamics, page 335. We're talking about the relationship between heat and work, and both heat and work are similar. Both are defined as energy that is transferred to or from a substance. So we have heat that's transferring to work, and you remember what work is. Work is force over displacement, force times distance. Excuse me. Force times distance is work. All right, or displacement. So a combination of substances is called a system. So we would call this whole thing a system. And an example is the piston and the wheel. Energy is transferred from the piston from the form of heat to the wheel in the form of work, because we're going to use heat to move the wheel. All right. Now in thermodynamics, in thermodynamic system, work is defined in terms of pressure and volume. All right. So work equals pressure times a change in volume. So the units are joules because it's still just a transfer of energy. So it's an energy unit. If the change in volume is positive, the work done by the gas is on the piston. If the change in volume is negative, then the work done by the piston is on the gas. And that'll become evident when we do examples, and you'll find that you have a negative answer, and it'll be clearer when we do an example. So let's try an example. Gas in a container is at a pressure of 1.6 times 10 to the 5th Pascal and a volume of 4 meters cubed. What is the work done by the gas if it expands at a constant pressure to twice its initial volume? So you can see our equation is going to be work equals pressure times change in volume, and you can see a change in volume in this problem, because the volume became twice that of the original volume, and we have our pressure. So what do we know? We know that pressure equals 1.6 times 10 to the 5th pascals. We know that volume equals 4.0 meters cubed, and then it's doubled, right? So work equals 1.6 times 10 to the 5th pascals times, remember it was doubled, so it's, when we do change in, it's the volume final minus volume initial, so it's 8 meters cubed minus 4 meters cubed, and so that would be work equals 6.4 times 10 to the 5th joules. The units are joules because it's energy. All right. So the second part of this number one is it is compressed at a pressure of 1/4 of its initial volume. Now here is, which is different from this one, is this answer is going to be negative. So we're going to have negative work, and so negative work, as we said before, is work done by the piston on the gas, as opposed to work done by the gas on the piston. So because it expanded, so the piston expanded, versus here it expanded, and so when it expanded, the gas did pressure on the piston, whereas in this situation it's going to get smaller. Anyway, let's move on. We're going to use the exact same formula, And now volume, if you recall, was volume was 4, then reduced by 1/4. Okay, keep that in mind. So we have work equals 1.6 times 10 to the 5th pascals times, and it reduced by 1/4, so 1 meter cubed minus 4 meters cubed. And so work equals negative 4.8 times 10 to the 5th joules. All right. Let's see here. So in this situation, the piston got smaller and didn't get bigger. The area got smaller, didn't get bigger. So instead of this direction, it went in that direction. All right? Number 2, a gas enclosed a container fitted with a piston. The applied pressure is maintained at 600 kilopascals as the piston moved inward, which changed the volume from to how much work is done. Alright, well that one seems, all of our data seems to be intact here. We go, basically I'm doing number 2. Here we have our piston connected to a wheel, as you can imagine, and this wheel is turning. And the piston stays still. The housing stays still, but the piston moves in. When it moves in, it moves. So it's out, and then as this turns, it moves in. So it's 5.317 times 10 to the negative 4th meters cubed. That's this volume. And then it goes to 2.52 times 10 to the negative 4th meters cubed. That's this volume. All right? So you can understand what's happening here. So work, we're going to use the exact same formula. Work equals pressure times change in volume, and pressure, we already know that P equals 599.5 kilopascals, and I've just come to see this. I don't even think about it anymore. I just come to see this as 5.99 times 10. Well, 5.995 to be honest. Let's give the sig figs times 10 to the 5th pascals. I just immediately in my head make all the units the same so that we don't have a problem. All right, so we know the change in volume. We know the pressure. So you just plug it in. 5.995. Excuse me. 5.995 times 10 to the 5th, and units are here if I'm confusing you. 2.52 times 10 to the negative 4 minus 5.317 times 10 to the negative 4th. It's our change, and then so work. What am I thinking? Work, here's our P, work equals a negative 167.7 joules because it got smaller, the area got more. So the work is done on the gas by the piston, and because the joules are negative. Alright, so the work is done on the gas by the piston, because it's negative, right? So let's try. I think we have time for one more quick one. Let's try number 3, or let me just double check, make sure. No, let's number 4. This is actually number 4. Steam moves. Yeah, this is number 4. My apologies. So this is a simple problem. However, there's just a wee bit of a snafu that I think you need to watch for. Just like this kilopascals in the last one, there's always something like that that keeps it interesting. Steam moves into a cylinder of a steam engine at a constant pressure and does 0.84 joules of work on a piston. The diameter is given and it travels, and that gives, and so we have, obviously we have volume data here. What is the pressure? So work equals pressure times change in volume, and so we know the volume of a cylinder equals pi r squared times height. So we have we just 3.14 times 0.008 squared times 0.021, and that gives us a volume of 4.2 times 10 to the negative 6. All right, and those are meters, of course, cubed. And so now that we know the volume, the pressure equals 0.84, we want pressure. Excuse me. This is work, joules. All right. So what we want to do is we want to solve for pressure. So we're going to have work over change in volume equals P, aren't we? We have to rearrange that. I don't know what I'm thinking. So it's 0.84 joules divided by 4.2 times 10 to the negative 6, and that's going to give us 2.0 times 10 to the 5th pascals, which are the units for pressure. All right. That's a nice problem. You recognize that you need this. This is in a table in the back of your book. This is considered common knowledge by now as a junior in high school, and you have to rearrange the equations. So this is a very nice problem for you to work.